I would like to introduce to you Steve, a fully programmable, movable robot that you can learn to control on your own. So let's get into how to build Steve. So we're going to start off by putting the motor controller on our breadboard. We want to make sure that that little split in the middle is in between the two rows of pins. So place it down and then press it down firmly with your thumb. Connect the two motor wires from each motor up to the motor pins. Now for this, we're going to be able to hook up the VCC ground and volt motor to the positive and negative rails and then attach those to the power and ground rails. At this point, we're going to add the PWMA pins to 6 and 5 on the Arduino. Then the AN1 and AN2 to pin A1 and A0, or analog in 1 and 0. And then BN1 and BN2 to pin A2 and A3. The final configuration should look exactly like this. From that, let's give Steve here a little bit of personality, I think. So let's grab our glue gun and have some fun. Perfect. Alright, now let's get Steve moving. Okay, so the first thing that we need to do in order to code this robot is to download our coding environment, or IDE, Integrated Development Environment, and that is going to be Arduino. So open up Google and go to arduino.cc. So arduino.cc is where all of the programs for Arduino are. So we'll go to Software and then Downloads. You can use the online tool, but it doesn't work really great. If you have a Chromebook, then it's not a bad option. However, if you're using a normal PC or Mac, then I would recommend just downloading the native application for your computer. Okay, once you're inside this area, now we're going to scroll down a little bit. I have a Windows computer, so I'm going to use the Windows App Installer. I'm actually going to install it directly off of the Windows App Store. So pop up, just hit just download, and then hit get for getting the free Arduino IDE. Boop. It'll open up the Microsoft Store, and then install. Once it's done installing, hit launch. Now we have Arduino. Inside the Arduino, we have two basic areas. One is the setup. Inside the setup, we put all the code that we want to run once at the beginning of the execution. So as soon as the robot turns on, basically. Inside the loop, we have code that will continuously run quite a few times, like somewhere around 1,000 times a second. So anything that we want to continuously change or move, like the robot itself, if we want to be able to move forward, backwards, left, and right, we'll have to put that in the loop code to make sure that it goes forward, then sometime later backwards, left, and right. So the first thing we have to do in the setup is tell our Arduino that we have some motors and what pins they are attached to. So if we remember, when we go back, we have PWM A, so that's the speed for motor A. Let's just list these out for now, just to make it easier. And A in 1, A in 2, so that's the polarity of the first motor. Then we have PWM B, B in 1, B in 2. And each one of these will equal something. And what they're going to equal is the pins numbers themselves on the Arduino. If we look at our PWMA and PWMB, we had pins 5 and 6. So we'll simply put 5, and then we'll end it with a semicolon, and under PWMB, 6. So this just says that the PWMA pin on the motor controller is hooked up to pin number 5 on the Arduino. And this semicolon is how we end each statement in C++, which is what you're coding in. Think of this just kind of like a period at the end of a sentence. Anytime you make a statement, you end it with a semicolon in this particular language. Sweet, that's all the setup that we need to do for telling Arduino what those pins are. And just to make sure that I can remember this, I'm going to enter a comment. How we make comments in this language is by putting 2 dashes. Anything that's after this 2 dashes on the same line will not be read by the program. So, pins for motor A. We can go down here. Pins for motor B. So now that we've given friendly names to all of our pins, such as PWMA for pin 5, now we can go in and set the mode of those pins to say whether or not they are output or input. An input is something like a button or a sensor of some kind. An output is a motor or a light or anything that outputs some form of signal. So what we're going to do to set that is pin mode. Very important that it is a lowercase pin and a capital M for mode. This is a case-sensitive language. So the pin mode for PWMA is going to be output because it's a motor. And then do the same exact thing for all the other pins. Now, if we look at this, you can see I didn't capitalize that M really quickly, right? So notice that it's a different color than all the others. So that's one way of diagnosing this. If something isn't working, you can take a look at this and be like, oh, this doesn't look like this. Maybe I forgot something. Oh, I forgot to capitalize the M in mode. Now that our pins are all set up, let's tell those pins to do something. So let's just set our speed for a motor so that it goes forward. So how we do that is by giving a value to each one of these pins. So the polarity of the motor works so that if one end is positive and the other end is negative, then it will spin in one direction. However, if I change that so the polarity is the opposite, it will spin in the opposite direction. So how I set that polarity is by telling the pin whether or not it is high or low. So high is positive. Low is negative. And it's that simple. So let's get rid of these and let's go down here and actually set them. What we're going to do is set our motor A to move so that A in 1 is positive and A in 2 is negative. So we'll say a digital write. So digital write means yes or no, true or false, high or low. Anything that is a binary option, either one thing or another thing specifically, is considered a digital write or a digital operation. Cool. So our first motor here now is set up so that it will definitely rotate in some direction. Now we just have to give it its speed. So how we give it its speed, because its speed could be more than just an on or off. It can be any range of values, in our case from 0 to 255. So because it can be more than just a binary choice, this is considered an analog write or an analog operation. So binary has only one of two choices, whereas an analog has an entire field or myriad of choices that you can go through. So same thing, only this time analog write PWMA, and we'll set a goes from 0 to 255, so why don't we name it somewhere around 150, and then again ending with semicolon. This should be everything that we need to get our motor A running on Steve. So originally I had planned on making this only one video to show both the hardware setup as well as the programming for Steve here. But because it was so long and I wanted to make sure that I got all the detail in, I ended up splitting it into two different videos. So the other video that goes over the programming of Steve is going to be released almost at the same time as this first video. So watch out for that in the next couple of hours to the next day. If you have any comments or questions about the setup so far, please leave them in the comments below. If you liked the video, give it a like. And if you're interested in more content like this, hit the subscribe button and follow along as we build all sorts of programs and all sorts of projects just like this one. Can't wait to see you in the next video.